Okay, just a quick update partway through the recap and, I guess you could say, re-resistor job on this Tram D201 hand-wired. You can see about half of the resistors and capacitors on the underside have been replaced already. As I had said before, I always use go 1 wattage higher when I'm replacing the resistors in these. So, like here's an original 2 watt resistor still in the radio, and then if you compare that in size to the 3 watts over here, so the surface temperature on these will stay cooler because there's just more of it, and likewise then surrounding components don't get as hot either because the heat can dissipate a little bit easier. Also, on a lot of these resistors, I'll leave the leads a little bit longer when I install them so they can get a little bit better airflow around them, especially, caused a problem over here originally with these. 2 other things on this radio. One thing I hadn't originally noticed was in the high voltage power supply circuit, so you've got your power transformer here, it's your main transformer. Down here, these small diodes, these are your rectifier diodes, which form a bridge rectifier for the high voltage circuit. Then it comes out of these diodes through these 247 ohm resistors. There's a capacitor, goes through this 100 ohm resistor here, another capacitor, and then basically feeds out throughout the radio and feeds high voltage to the entire radio. So all of the tubes receive their high voltage through these 2 resistors that are in parallel and then this ceramic resistor. So you really don't want to be messing with these. Well, that's exactly what somebody did. If you look down here, these are all parts that have been replaced so far, and one thing you'll see down here is a little piece of wire. Someone had this piece of wire jumpered across these 2 resistors here, effectively taking them out of circuit. I don't know why they did that. Maybe it was an attempt to raise the high voltage, which is exactly what that would do. It would raise the high voltage. The problem with that is it raises the high voltage throughout the entire radio, and you have to remember the circuit, the entire radio circuitry was designed around a specific voltage coming out of the power supply area of this radio. If you go messing with the high voltage here, you're affecting it everywhere in the radio, and you don't know what adverse consequences that may have. It's not uncommon to do. There is a modification that's common on these radios, and that's to increase RF output power. Here's your RF final tube, and these 2 resistors right here are dropping resistors, so they effectively lower the voltage going to the final tube, which lowers the power. So, matter of fact, if we pull the schematic out here, I can show you those 2 resistors. So, if you look right here, here are those 2 resistors, and you can see that's for AM mode. Through your modulation transformer, they come up. There's the neutralization link, and to your final tube. So what a lot of people will do is, which is what someone had done here, they add a switch to effectively remove those 1 or both resistors from the circuit. Now what someone had here, it's these 2 wires, this pair of wires here go to a switch. They had 1 wire goes here, 1 wire goes here, because these resistors are in series. So when they put the switch here and here, when they flip the switch, that effectively removes both of these out of circuit, and it just bypasses straight through. I don't recommend doing that. The reason I say that, the only radios, Tram D201s, that I have personally ever worked on that had power transformers that burned up, I mean literally caught on fire, flames shooting out of them, the only ones I have ever changed, the only radios, the only thing they had in common, I should say, was both of these resistors were bypassed. So that should tell you something. You're asking a lot more of the radio. It's going to be drawing a lot more power when you do that. Now, you can safely bypass one or the other. I do not recommend, however, bypassing both of them. So if you want to take these, take a switch, jumper across this one, or you can do both. Some people will do that. So they'll have 3 power levels. You'll have both resistors in circuit, your factory power, bypass one resistor. If you bypass this one, that'll get you an increase in power. And then if you bypass just this resistor, you get an even bigger increase in power. So that's one way to do it. Like I say, I don't recommend bypassing both of them. But like I say, the main thing I wanted to say here was don't mess with the high voltage circuit. Doing the modification here, the modification it's modifying the voltage going to this tube is only modifying the power that goes to only this tube. Doing that whoever did that modification over here by jumping out these 2 resistors, by doing that, they're modifying the voltage for the entire radio, every single vacuum tube in this radio. So, don't go messing around with stuff like that. One other thing, I have not changed it yet, I wanted to leave it in here, was that you should always change in any tube radio. I don't care how good it works. It's something most nobody ever changes. And I see a lot of these, especially on these trams, flame out. You see this, especially when you look at it like this, it looks like a normal ceramic capacitor. It's not. It's a dual element. If you flip it up here, you can see it actually has 3 leads. It's got this one lead here that comes out and goes down to the ground strip. So the safety capacitors, well, this isn't even a safety capacitor. It's just a normal Z5U rated capacitor, so at 1 kilovolt. So what you'd want to do is, now what I personally do is I'll actually add 3 capacitors to this. I'll add 2 line to ground, which is what this capacitor acts as. So it'll have 2 capacitors, one from here to here, one from here to here, and then I'll add a 3rd capacitor, which is an across-the-line filter cap. So I'll add another one. And your safety capacitors, I use the multi-rated, which are X1, Y2 safety-rated capacitors. Like I say, they didn't have safety-rated capacitors back then. So, and like I say, I have seen these completely burn out, blown into pieces before, because this is probably the hardest working component inside this radio. Even when the radio is turned off, it could be plugged in for 5 years and you never turn it on. This capacitor has been active for those 5 years because it's always, you have to remember, it's always connected to the power. As long as this radio is plugged in, this capacitor is always in circuit. So any voltage spikes come through your power line, everything. Matter of fact, that's the same pretty much for anything electronic. They're all going to have these capacitors. So like I say, even when something's turned off, these capacitors are in line 100% of the time, unless you're turning off the power to the power line using terminal power strips, which is what I do, which completely removes, even my test equipment. End of the day, I've got power strips. I turn the power strip off, that removes power from everything. So like I say, always change these, and make sure when you do, always use modern safety. They're safety rated for a reason. They're meant to not catch your radio on fire when if one of those safety rated capacitors goes bad. They're designed not to flame out like these capacitors will. 'Cause like I say, I've seen these literally flames blow out. Now, luckily the transformer didn't catch on fire, but I had seen it burned the paper, a small portion of the paper wrapping on over the windings here is burned off. So that's just something to keep in mind. Always change your safety caps. And when I get the underside here completely done, I'll make sure I take a picture of how and what I installed in place of this original safety cap. So, to return later.